We're working. We're live. Let's start this one. So much tech. All right. We have.
Is it so? There's like a Kickstarter stream of comments and a YouTube stream of comments.
And Facebook. I've set it up for everything.
Oh. The Kickstarter one isn't on yet.
That's because I haven't gone live yet. There it is.
It says it's live in 52 seconds.
Okay.
Okay, we need 3 devices then to monitor the questions from 3 different. I can monitor the YouTube ones.
What the world? Oh, so Telly's. We're just trying to set up the tech. It's very complicated. We have 3 streams going off all at once.
Oh, okay.
You're live. Awesome, cool.
Okay, I have it on YouTube. Hey, Telly. Also, hi, Terry. How's it going?
All right, so it's been 15 minutes and we're at $13,000 back, which is pretty good.
Wait, where's the? Grab your thing.
What thing?
Grab the thing.
Oh, this.
Woo!
All right, so I'm just gonna pull up the live stream on my phone so I can read the questions. We're using 2 laptops to see what's going on. So there you go.
I already have that one open.
Okay, great. I'll pull up the.
Yeah, open up one of the other ones.
Okay, I'll check if Facebook is working properly.
We're delayed by, I think, a couple minutes, so, or at least 1 minute. Telly's given us permission to post updates on his Facebook page whenever we want to.
All right, cool.
Thanks, Telly. Glad you like our machine and the stuff we work on. Have you pulled up any of the other stuff?
I can do a dual. I can do 2 screens at once on my phone, I think. So I'll pull up.
Everyone, this is Louis. He's the real CEO of our company. He's the evil genius behind all of our designs. What we do is we take a piece of paper that has yes written on it and another piece of paper that has no written on it. And then we ask him if he wants to do something or not, and then he puts a paw on it. And that's how we make our decisions as a company. I think I'm going to twist the laptop camera just a little bit. I think that's better. So we don't have any questions for now, probably because we just started the stream. But I did bring out some stuff to show off in the meantime, other than Louis here. because in the rewards for the Kickstarter, there's like a t-shirt and a dust mask. I was going to show those off real quick. So this is the t-shirt that we have that we're going to print more of. It's more of just like a swag item. If someone can't afford a CNC machine but still like what we're working on, then they can financially back us by buying one of our t-shirts and just show their love for what we do. And
so Telly has a question, which is, how you guys feeling about the new machine? Looks awesome. Well, do you want to answer that, or do you want me to answer that?
You go for it.
Well, we feel pretty good about the machine. Obviously, that's why we're sharing it. Well, one of the biggest things about the Mill 1 was that people really liked it because it was really inexpensive and easy to use. And, you know, we focused on making the machine as high performance as we could with the price point in mind. And, you know, people really enjoyed using the machine. And I think the experience with using a LongMill is even better because, you know, you get more power, you get more workspace. So, yeah, essentially, when I use the machine myself, it makes me happier in a way because it's more satisfying to watch it work. Yeah, and it looks like it is a beast. It's definitely a beast. So I did see another question from in the comments section asking by Nathan, who was asking about the Millwright Carve King and the power route. The first thing to know is that the size of the Carve King, I think it's 14 by 14, so it falls under the, like, I guess it's comparable to our 12 by 12. Price wise, the LongMill here is about the same price, but you get much larger motors. You get the linear guides on the Z-axis. It's fully open source. It's just a much more tough machine, in my opinion.
Mm-hmm.
So
you've got the steel gantries as well instead of the aluminum gantries.
Yeah.
I'd say the only place where our machine doesn't have something that the Carve King does is that our machine is a platform that's attached to whatever base you wish, whereas the Carve King has its own base with a T-slot track. So
I think one thing to consider is that the pricing for the machines here are pretty similar to a lot of the like the hobby grade machines, but when we're at the woodworking show, a lot of people are comparing it to like the high-end professional machines in terms of like the performance and the rigidity, and you know, we kind of are starting to bridge that sort of area where, you know, these machines can be used for semi-professional use. So yeah, that's my answer. They also mentioned the power route. I haven't really looked too deeply into that. I do know it's more of a big machine. I think it starts at like $2,500, $3,000 ish. So maybe it's more. So there's that thing to consider too. We have Bob asking, how you guys build a mill when you aren't real carpenters? Good question. So Chris and I have a background in engineering. We actually met in first year mechanical. So at least for me, I had used a lot of CNC machines in my work. I know, like, you can talk about like your 3D printing background.
Yeah, I actually have like 6 years of experience with woodworking because I took it like every year through high school, and I also pursued it as a hobby after the fact through my university. And I also have a lot of experience with 3D printing technology because I think 5 or 6 years of 3D printing experience, both building them and using them and printing parts for other people as my own mini business. So, you know, even though neither Andy or I have necessarily in-depth woodworking experience, I would say that the feedback that we've gotten from individuals who have been woodworking for decades has been very valuable for us, because we've had beta testers who are decade-long woodworkers, and we've been working alongside them to make the finishing touches on our machine.
Mm-hmm. Yeah, so essentially, like, between me and Chris's experience and, like, with our beta testers, we can, build a machine that works for everyone.
I think there's a comment on the Kickstarter.
Yeah, let me just read that. It's your dad. Excited for you guys. LongMill looks amazing. All the best for your second Kickstarter launch. Chris's dad. Well, I'm glad he's there. We have another question from Jim. Well, Jim wants to see the machine operate, but I think that we'll probably do another live stream or a webinar on using the machine later on, where we'll actually show the machine being used live. But he's wondering about the start price point. So the early bird machines for the 12 by 12 is $950 Canadian. The 12 by 30 is 1,100 Canadian, and the 30 by 30 is 1,250. Mm-hmm. And then you can add on different things if you want. So yeah. What else do we have? Let's just quickly check where we're. Oh, damn it! Kind of screwed up the line.
While you're looking, I can go back to showing off the rest of the swag.
Okay.
So I showed off the T-shirt, which, as I said, is there for if you want to support us but don't have the money to buy a machine. We also have these awesome custom-made dust masks here, and they just kind of go on like this. They've got a custom CNC logo on the side, and they're really good for coarse dust. We have the filters for them here. They come with the dust mask. And we also have some of the sample projects that I'm sure you guys have seen lots of pictures of, so you can see them live on the video. I've got the topography of the mountainscape here.
We can show them this one.
I'll leave there. This is the new carving that I did of a ram. We're going to have a video for this in the next few days. And this only took 3 hours, but you can see, I'm going to step over here. You can see the kind of detail that we can get on the machine and repeatability. Seeing the grass and the trees and the mountains in the background as well as the water. So I'll put that up there. This is the first aluminum test we did on the machine. Turned out very well. It's kind of a mechanical Tyrannosaurus Rex. And we've also got, this is a piece of wall art that I designed. You probably saw the video for that. Carved from both sides to get a water droplet effect. Plus the design on the back connects all of them together.
You're pointing at the wrong camera. There are two different cameras there.
Oh, I see.
So maybe show it to both.
Oh my. So both cameras, okay. There's this, the wall art. Should I grab the other stuff too?
Yeah. Let me change the view so that you can see it more easily where you're pointing. Yeah, there you go.
Okay, here. I'll show it again. This is the carving of the ram. And you can see the detailing of the trees, the water, the grass. It only took about 3 hours to make. I'll show it on this side again. And this is the aluminum T-Rex that I cut out on the machine. Very nice in 3D, and it shows the ability for the machine to not only cut profiles out of aluminum and other soft metals, but also contours. And then the last one was I brought this chair over, which I'm not going to be able to get on camera, but it's made on the machine. It shows that you can get a really good size cutting area for the machine, so you can cut out small to mid-sized furniture, as well as a variety of signage, as well as other detailed reliefs and sort. Oh, I should grab the CNC Lab sign as well.
Bob's asking if there are no safety features there. Also, can you demonstrate how to unclog it when it gets jammed? So with the safety features, the electronics box, I don't know if you guys saw in the photos, but there's the red, yellow, and the blue buttons. Those are for the emergency stop, and then the pause and play buttons. We're still we're working on making it look better. But if the machine kind of goes crazy, you can press the red button and it'll stop the machine. We do recommend that users have an eye or an ear out while the machine is running. So there's that to know. A lot of the things that we learn about machine reliability, that's kind of come down to making sure that the machine itself is reliable, so that people, the machines don't, I guess, break on themselves, if that makes sense. For example, if you have if you have a machine that's not rigid enough, what you can run into is the machine flexing and breaking something, or if the motors aren't powerful enough, they'll kind of stop cutting, and it could burn the wood. But with this machine, it's kind of a good balance, because the machine is powerful enough to really go hard on the materials, but they're not at this where they're so powerful that the machine will rip itself apart if the motors stall or something like that.
Yeah, when you say jammed, the machine doesn't exactly get jammed. There's certain maintenance that you have to take when you're using a machine like this that any machine operator would tell you. You want to keep your linear axes relatively clean, because there's moving parts and you want the machine to stay accurate. So you want to wipe those off occasionally so there's no gunk buildup. And you want to make sure that your lead screws are clean, and they don't necessarily have to be lubricated. But certain lubricants do work to keep the mechanics running smoothly. But other than that, the router that comes with it, in our experience, we've been using this router specifically for over 2 years on our machines for all of our testing purposes. It's never jammed, and if you push the machine too hard, the machine will never break itself. The only thing that ever breaks is the cutting bit. So there's really no jamming that occurs when you're using a machine like this.
There's some questions on the Kickstarter. Let me see.
Wow, you're very close.
Oh, it's Tom. Yes, indeed. He was one of our beta testers for the mill one, actually. So hi. We have another question on YouTube, on Facebook, asking, let me see. Does the price include everything I need, including programming to start making projects? The answer is yes, but you'll need to get a router and a base. There's more details in the campaign page, so if you read through it. So for the router, you can use the Makita router that's here. We'll also support a bunch of other routers, and there's a list of suggested routers in our Kickstarter page. You can also buy it straight from us for 150 Canadian dollars. So if you do decide to get the router through us, just add plus $150 on your pledge. The base, we recommend using a 3/4 inch MDF sheet. The 12 by 12 will use a 2 foot by 2 foot piece. The 12 by 30 will use a 2 foot by 4 foot piece, and the 30 by 30 uses a 4 foot by 4 foot sheet. So we made it pretty easy to go to like Home Depot or Lowe's or any hardware store that sells sheet material. You can ask them to get it cut to the size you want. And we did that because shipping that material when you can buy it at the hardware, like shipping it would cost probably like $50 to $100. And we figured that, you know, if you can buy it at the store for like less than $30, you might as well just go to the store and buy it there instead of spending, you know, $100 on something that is kind of expensive. Yeah, $100 on something that's expensive to ship. We can put more money into making the machines better rather than, you know, giving it to the couriers, I guess. Right?
Yeah, for sure.
Yeah. Scott's asking if we tried using a spindle, like probably a 1.5 or 2.2 kilowatt 3-phase spindle. We haven't yet. We do. I do think that it's gonna be possible to support. We have spindles in the office for different machines that we're building as well. So if we get around to it, we'll try supporting the 3-phase spindles. I would say it's probably a bit on the big side. And you know, there's also the cost involved. I think a spindle and the variable frequency drive will probably run about $300 to $350 Canadian versus like $150 for a router. So yeah, we'll have to check it out. But theoretically, it should work. But I wouldn't promise anything right now. I would probably stick with one of the smaller routers, and once we have the testing done, we'll let everyone know.
Yeah, the spindle control is something that a lot of people are interested, or that people have expressed interest in before. I would say like the perks of having spindle control is that you can have your variable speed controlled by the controller, and spindles usually have less runouts than the routers do, but not by a super wide margin. So in terms of incorporating a spindle, as Andy said, we could look into it to have some pinouts so that you can connect it to your VFD for controlling the VFD, like spindle enabling and spindle direction and spindle speed, because that's been something that we've been experimenting with on one of our other machines. But yeah, that's still to be determined.
There's some people on the Kickstarter feed right now saying that they can't hear. Let me try if I can fix the audio, and I'll also put a link on the comment for one of our YouTube live streams. Let's see.
I can hear it on YouTube.
Okay.
I can hear it on the Facebook as well.
Okay, then it must just be. Okay, I've put the link on so that people can.
I lost the line.
Oh, yeah, I'll find it. Okay. There was one backer saying that they had been charged for the credit card. They had their credit card charged and not on April 25th or the day before it finishes. And they're also saying that they weren't able to add the extra add-ons. Could you explain how the add-ons work, and I'll see what I can find out about the Kickstarter stuff?
Yeah, so if you scroll down in the campaign, you'll see more information about how the pledging works. Essentially, we have a variety of add-ons. We've got the router add-on to the machine. So if you don't already have a router, or you would like to use the Makita, which we would recommend, then you have to add that on to your pledge. As well as there is a Z height probe that you can use for tool changes. There's a dust shoe that we've designed specifically for this machine that's easy to remove, as well as you can attach a regular size vacuum hose from a shop vac or what have you for easy dust collection. And I believe those were all of the add-ons. And so you'll see a chart a little bit further down the campaign that shows the prices for each of those add-ons. And the way that you attain those add-ons is you basically take the price of the machine and add the price of the add-ons onto the pledge. So say, for example, you want to get a 30 by 30 machine, and you also want to get a router and a dust shoe. You'll take the 1250 Canadian, and then you'll add another 150 for the router, and add another, I believe it's 45 for the dust shoe. And then the math of that number, which I can't do in my head right now, is the number that you're going to write down for your pledge amount. And then we'll see that number, and we'll know exactly what it is that you're getting alongside your machine so that we can ship it to you.
I try to look into when people get their credit cards charged. According to Kickstarter, they say that they get charged once the campaign is ended. If you are getting charged before that, get in touch with me and we'll try to sort that out. It may have been a charge for something else, or Kickstarter might have charged it for some test or like how do you say, confirmation. I don't think it should be charged. I think we've backed Kickstarters ourselves, and we haven't gotten charged before.
Yeah, the card shouldn't be charged until the end of the campaign.
Yeah, so I'll try to look into it more. It sounds like it might just be a one-person thing. So yeah, we are at $25,000. We're almost halfway there, guys. It's much better than the mill one.
Yeah, we're pretty excited about our new machine. It's a very rigid machine. It really doesn't move anywhere, and its ability to cut like hardwood, soft metals in a larger cutting space is very nice. Our beta testers have been very happy with their machines. They've given us great feedback, and it's been helping to improve their businesses quite substantially. I'm sure if you haven't already, I would encourage you to scroll down in the campaign and take a look at the interview videos that we published by 3 of our beta testers. Those are just 3 of our 10 total beta testers that we sent machines out to. They pre-purchased them because they knew about us, they liked the design of our machines, and they wanted to help us test our new design. So it was really nice of them. And they really enjoyed, like, some of them, it was their very first time ever using a CNC machine. And so our machine acted as a great platform for them to learn on. And others, they had previously purchased our smaller Mill 1 machine, and they liked it so much, and they learned so much from it that they wanted to improve the abilities of the machine that they had so that they could make larger projects and they can do cooler stuff. So they happily got in contact with us because they wanted to find out about our new machine and see if they could buy one. So, and that happened about 7 months ago. So we've been doing testing for a long time. They've been doing testing on their own machines and giving us great feedback. And that's why we were finally confident with the design of the machine. It had worked for 10 individuals other than ourselves, as well as we've done countless hours of projects on our machine in the shop. And yeah, after making all the upgrades, we felt like we were comfortable with finally releasing the machine to the rest of you.
There was some, seeing if there's anyone else who has questions. Does anyone else have questions?
Can you access the Kickstarter questions?
No, I have to look it on the screen there.
If anyone else has any questions, then just ask in the comments on either the Kickstarter live stream, the Facebook live stream, or the YouTube live stream, and we'd be happy to answer them.
We're also going to put the FAQs up on the Kickstarter page. We actually pre-wrote all the lists. Like we got like probably hundreds of emails with questions, so we broke it down into an FAQ page so that we're going to post it up on our page as well. But if anyone has questions, like we'll also put those up on the FAQ as well. So,
if we're waiting for some more questions, I'll show off some more of the stuff we've done with the machine. So this sign here was actually graciously made by one of our beta testers. So it's actually just a piece of 3/4 inch MDF. And he went and he cut out our logo out of the sheet of MDF. And then he actually went in and hand painted the tops of the lettering to give this really nice finish and gave it to us so that we could have it in our shop. So this is like a really nice, legit sign. We finally have a legit sign.
Yeah. So all our backers are gonna send us nice things that they made with the mill too, right?
Yeah.
We could talk about like how like the Kickstarter is gonna help us with how do you say, the production?
Sure. Yeah.
Yeah. Well, I think I mentioned in one of our emails that it does help us a lot if people are backing the Kickstarter early, because it helps us make decisions and make purchases and production even during the Kickstarter. I know that a lot of the people out there, they really want the machine like as soon as possible, and you know, reality is that it takes time for us to build machines, and so we're doing everything in our power to build the machines as quickly as possible, make sure that they're the best quality as possible.
Mm-hmm.
But you know, if we wake up tomorrow and we see, oh, there's like 100 people who are wanting a long mill, then it means, okay, well, we can start building the first kind of a batch, or like start to work with our manufacturers even earlier on to be able to get a jump start on the production as well. There's also a lot of design choices that kind of scale up differently. Like for example, we have a lot of 3D printed parts, which is really good. But if we were to, let's say, build 500 machines, then we would have to use a different technology to manufacture them. So we can use sheet metal or injection molding for those things as well. So it does really help us in terms of helping our backers as well, if we know, you know, what kind of demand we have for these machines.
Yeah, having this round of pre-funding for the machines is important for us because we want to make sure that we can give out the highest quality machines possible based on the interest that exists for the machines, as well as, you know, we want to make sure that we are sure of the interest, and as Andy mentioned, we can make sure that we use the necessary manufacturing technology to make the machines to the highest level of quality that we can, based on that interest, because manufacturing of the machine is going to change based on if there's only a demand for 50 versus, 1,000.
We have a question by Isaac asking if people can do pickups. The answer is yes. So if you back us and you pay shipping, we'll refund the shipping back to you if you do pickup. That's what we did for our last Mill 1 campaign. And yeah, pickups are cool.
Yeah,
it does help us too, because then it means that we don't have to worry about the couriers and whatnot.
Yeah, it also means that there's no issues with potentially having parts broken in transport, even though we make sure we design our packaging to hold up to all of that. But I think above all, the coolest part about picking up is that we get to meet some of you guys in person.
Yeah.
Which is the most fun part for us. Anytime we hear a customer lives nearby, or anytime we're at an event and someone says, "Hey, I bought your machine," then it's really fun talking to them, and we also are always interested in inviting them back to our office so that we can give them a tour, so we can show them, where their machine came from. And
maybe we should just start we're gonna have so many people coming to our office to do tours, we won't be able to get time to build machines.
Okay, if hundreds of you want tours, we'll just arrange a day where we could have time frames for tours.
Yeah.
But we wouldn't say no, that's for sure.
For sure, yeah.
If you guys haven't done your thorough research or don't already know, we're located in Kitchener, Ontario, in Canada.
There's more questions here. YouTube link. Do these come as a kit then? Yeah, okay, so Tom is asking if the kits come with the wooden base, and the answer is no. As we mentioned, you'll also read in the campaign that we use that as a way to save costs by getting people to buy their own bases. But the beauty is that you can use any material to make a base. We recommend the 3/4 inch MDF because it's fairly inexpensive, but you can use plastic or like an old table or anything like that, and you'll be able to basically lift the whole machine off of the base, put it on a new base, so you can have that flexibility as well. We have another question.
To Jim, sounds good. We'll see you at the office. And also to Dale, as we said before, the Kickstarter will only charge upon successful completion of the campaign. That's just because some Kickstarters, when they're started, they don't reach the funding goal that the creator of the Kickstarter is looking for. And so if the goal is not reached, then Kickstarter wants to make sure that it can refund everyone who's pledged.
Well, you don't have to make a refund if nobody got charged, right?
Yeah, sorry. So if the goal isn't, or if the campaign isn't successful, then it doesn't have to refund anyone because it hasn't charged them yet. But judged off of how our Kickstarter is going, I think it is definitely going to be successful. But yeah, you're only going to get charged for it once the campaign comes to an end. And yeah, once that happens, then there's a bit of a processing time. It's usually around 2 weeks, and then Kickstarter will release the money, like the funds, to us, so that we can start purchasing the parts that we need to make you guys' machines.
Scott's asking what sort of 3D printers we use. We actually have 6, I think, or 5 active ones. We have 2 Cetus printers. Those are made for tier time. We actually backed one of them on Kickstarter a couple of years ago that you use.
Yeah, I backed one on the Kickstarter personally, and it was such a good machine that we ended up buying 2 more for our business.
Mm-hmm. We have 2 Prusa Mark IIIs, i3 Mark IIIs, and we have one Wanhao printer, and we have a couple that are in a box on the shelf there that we need to fix.
Yeah, I think we had 2 other wand pals
Yeah.
and one other, I can't remember the name of the other one that we had.
Mhm.
But our printers have worked like thousands of hours.
Yeah, I think there's one that's like hit about 3,000 hours at this point.
Yeah.
That one is a grandfather. That's a beast.
Yeah, we work them to the bone. We fix them if anything goes wrong, and we have a lot of spare parts. But our printer farm has worked really well for us. We keep our farm running as often as we can to make new parts, because we need to generate the parts for our Mill 1 machines, and also all of the prototyping required to make our LongMill machines and to iterate on their design, as well as to print all the parts for all of our beta tester machines.
And the beauty of using 3D printing is that we can make changes on the fly. We can make modifications. If, like, for example, with the router mounts, what we're gonna do, which is what we did for the Mill 1, is collect all of the different sizes for the routers, and we'll have like this repository of different router mounts so that people can print their own, they can make their changes, or we can supply all these different types of mounts. So
Yeah,
it really does. Yeah.
In the Mill 1 campaign, most of the mounts that we shipped with our machines were for the Makita, but we designed a special mount that worked with the Makita and then came with a shim for a rigid router, so that you could take either of those. We also designed a mount for like the DeWalt palm router. We designed a mount for a couple Dremel tools. So I don't think you'd want to use a Dremel tool on a machine like this, though.
Yeah, it's not powerful enough.
Yeah.
We have a question by Paul who wants us to describe the learning curve for someone who's not familiar with CAD and CAM.
Sure. Yeah. Well, we did a live stream last week, which goes through the process of. There are essentially a variety of tool chains that you can follow to get from idea to making it on a CNC machine. And we're always trying to work to make sure that that process is as easy as possible. So so based on how you want to start, it'll determine the process that you follow. So for example, if you want to start with a drawing to make a 2D cutout, like for example, something like this, there's no curved profiles on here, so it's only 2D. This could either be made as a 3D model or as a 2D drawing. So you can either use a vector image program in order to draw these shapes. So Adobe Illustrator or Inkscape, or I don't know if there's any other ones that are popular. Or you could find a vector design like this online and download it as a vector image drawing.
Yeah, like a picture.
Yeah, like a picture. And so either way, if you either make it or download it, there's a variety of programs that you can put the picture into that'll basically turn it into the tool paths, like the carving path that the machine will follow in order to cut it out. And so some of these softwares are like MakerCam and F-Engrave and Carbide Create and Easel. And all of these softwares, essentially you put in the cutting tool that you use, that you're going to be using on the machine. So maybe an 1/8 inch router bit or a 1/4 inch router bit or anywhere in between. And once you give it the tool parameters, it'll just figure out the position that the machine needs to go to cut the part out, and it'll export a file that you can then put on the computer that's plugged into the LongMill, and you can run that file so that the LongMill will cut it out. The other process that you follow is for 3D models, but it's very similar in that you can either make a 3D model or find one online. We have some resources for websites that are very popular online that you can find a variety of 3D models on for CNC use. And once you have that 3D model, you can import it into your software, generate the cutting path, and then run it on your machine. So you're going to see in the next few weeks, on top of the live stream that we already did, or yeah, the live stream that we did, we're planning on doing a couple webinars to show off the process of going from different starting points to the carving endpoint of making your final part. And that would give you probably the best idea of that process if you want to know more of the specifics on what that process looks like.
Mm-hmm. And just to put things into perspective, because a lot of the things that Chris might have said might be a little bit confusing. You know, once you get into the software, making something like making the programming for like the aluminum dinosaur, or like I mean all of these projects here, you can program it within 5 to 10 minutes, I would say. And so we will.
Yeah, and well, I wouldn't say program is the right word, but
it's more like setting the right number, like making sure it's going at the right speed, and using the right tool, which I think is probably one of the bigger challenges. But you know, we have a list of suggestions that people can start with, and we a big chunk of our beta testers haven't used CNC before, and especially with the mill one as well, where our users, about 70%, have never touched the technology before. So, you know, if those people can do it, I'm pretty confident that anyone here are able to do it as well.
Yeah, for sure.
Let's see what other questions we have. What's the travel in the z-axis? That's about 4 inches. It's 4 inches. If you need more travel, what I would recommend is shimming up the feet, like the feet here. I don't know if people can see it. Yeah, you can shim up these feet here, and that'll give you a bit more working room. Yeah, these feet here. Or you can also cut the middle of the base out, and then you can cut through the base as well. But yeah, that's probably...
Yeah, if you want taller milling height, you can stick the entire mechanics here actually up on spacer blocks. Your carving depth is only going to be 4 inches, but you can carve things that are much, much taller if you find that you can't fit it under the bed height constraints that the machine has by default. I'll quickly answer Dale's question about if the machine's CSA approved. The way that our machine is it's a kit. All of the individual components of the kit are CSA approved, but the machine as a whole isn't CSA approved because, like, when you have individual components and you assemble them together, then those now need approval. Because you guys are assembling them and we're not, it's impossible for us to approve it once you guys have assembled it, but all of the components on our side individually are safe to use. And the machine comes with a power brick so that you don't have to do any wiring of mains electricity, so that you guys are safe when you're setting your machines up for the first time.
Another person asked about how to put the add-ons onto their pledges.
Oh, okay. Yeah, so I'll say again, if you want to have an add-on into your pledge, so let's say, for example, you're buying the 30 by 30 LongMill, and you want the dust shoe, and you would also like a router, then you just click on the pledge for the 30 by 30 LongMill, and you'll see the price pop up at the bottom there. Before you hit pledge, what you want to do is take that price, which for the 30 by 30 LongMill will be $12.50 Canadian. You'll add $150 to that for the router cost, so that'll make it $1,400. And then you would also add, if you're getting the dust shoe, it's $45, so you add $45 to that. So your pledge would then become $1,445, and then you hit pledge. And once you've done that, we'll be able to figure out what add-ons you have requested, and we'll make sure that we package those in with your machine and ship them out to you.
We also have someone asking whether the rigidity of the machine will be affected if they do raise up with, like, if they raise the feet up. The answer is it depends, but not likely, or like not enough to make that big of a difference. if you think about what's kind of flexing in the machine, everything will stay the same essentially except for where the feet are. So if it is longer, you can have a little more play back and forth. But if you're using something that's bulky enough, then it won't flex. So
yeah, so I would. So basically, what Andy's saying is the additional flex that's introduced to the system would be dependent on the spacer material that you're using. Obviously, if you put the machine up on spacer blocks that are made of like foam, then now it's not got a very rigid mounting to whatever the final base is, and that would cause flex between the machine and the mounted base, which is where you're going to have your material mounted. So I would make sure, if I was considering raising the machine up, I would ensure that the way that I'm raising the machine up is in a way that's very sturdy, so that the machine is not losing rigidity from the mechanic side to the base. Yeah.
Anyone else asking questions?
I was trying to bring up the Kickstarter here, but I forget that.
Oh, okay. It's fine. I can see the questions coming down the stream. Yeah.
So we answered all the Kickstarter ones because there's quite a few there.
Oh, did we talk about how to do the Z-axis homing?
No, we didn't.
Okay, let's talk about the Z-axis homing.
Is there anything else?
Will you make the dust cover 3D file available for download?
Yeah, after the Kickstarter is done and we've finished the design for the dust shoe, then we'll make it free to download, just like the plans for the rest of the machine. It is an open source design, just like the Mill one is. So for the Z homing, essentially the process is as follows. First, what you want to be doing is sticking your end mill into the router and securing it in place, because based on how far you put the bit in, that's going to change your Z origin height. And then there's actually a variety of methods that you can use to determine your Z height. So for example, if you set your origin for the cutting file so that your starting point is at the top of the material, then what you want to do is you can either lower the bit down close to the top and then stick a sheet of paper underneath and lower the bit until you can feel the bit grab on the piece of paper. And then you'll know that the bit is very, very close to the top of the surface, and then you can set your Z height. One of the more advanced ways that you can do it is actually one of the add-ons that we have for our Kickstarter, which is the Z probe. And so what happens with the Z probe is that you can actually plug it into the control box for our machine, and in the machine interface you hit set the Z height, and it'll automatically move the Z axis down until the bit makes contact with the probe, and then it'll back off, and then it'll slowly go back up to it to make sure that it knows where it's at. And then what it'll do is automatically set the Z height for you. So you put that Z probe on top of your blank material, and then bring your bit down on top of the probe. Maybe I could grab the probe if I want to demonstrate that a little bit more visually.
Right. Well, we do have a GIF on the page as well, so if you guys want to see like a GIF of it, it is there. We have someone asking what's
Right. Yeah, check out if you can't visualize what I'm saying, there's a GIF. If you scroll down to the Z probe or to the add-on section, you'll see the GIF of what I'm talking about, how it does the Z height setting.
We have someone asking what's the difference between the $1250 and the $1,300 option. They seem the same. They are the same. One is for the early bird. So if you back our campaign within the first 3 days, you'll get the early bird pricing. If you back it later, then you'll get the not early bird pricing. And that was just to encourage people to back earlier rather than later.
Yeah, we're essentially just saying if you have been paying attention and you make the decision to buy the machine earlier rather than later, then we're going to give you an extra $50 off because we really appreciate you showing your support. And so that pledge is only going to be available for the first 3 days. And after that point, our campaign is going to be running for 30 days. So after the 3 days, for the next 27 days, the only option is going to be the $1,300 one.
We have a question, if there's going to be homing, like I'm guessing homing switches with the machine. The answer is the machine will support homing switches and will provide some support with that.
We don't have an add-on kit ready for it right now, but we might, if there's enough demand, we'd be interested in making an add-on kit for homing switches that we can distribute once the Kickstarter machine starts shipping.
The electronics already support the end stops, so it's just a matter of plugging them into the right place, which makes it really easy to install. But for the most part, it's not necessary to have end stops, so we have chosen to not have them for simplicity, but I do know some people do like having them, so people have created like ways to add them onto the Mill 1. I'm sure people will do it for this, but I feel that we will have support for the end stops and probably an add-on kit later on.
Yeah, so if you've never used a CNC machine before, unlike a 3D printer, end stops are much less valuable for a CNC machine. And the reason for that is because the home point of the machine is less as important as the origin point that you set for your material. So once you have your stock material and you've located it on the bed of the machine, you're going to be setting a home point so that the machine knows where that material is. And what you're interested in is not losing that. You're less so interested in knowing the origin of the actual machine. So say you're say you're running a job and something fails for one reason or another, it can happen. Even if you did have homing switches, it's not a guarantee that you can re-find your position. What you'd be more interested in is just like the machine knows its coordinate system, and so you want to make sure that the computer that's powering the machine isn't like turned off at any point, because if the machine's turned off, if the computer's turned off, then the machine won't know where it is. So the only thing that's really important for CNC machines is the Z height, which is why we do have the Z probe, because that's a lot more important for doing tool changes, for example. If you want to remove a large quantity of material with a larger bit and then switch over to a smaller bit to add the details, having a Z probe enables you to make those tool changes quickly and easily.
We had a question on the comments from one of our beta testers. They're wondering if they'll be able to use the dust chute on this machine, like is it compatible with the beta machines? Which is yes, they are compatible, but there is a small change in the the x-axis plate to add a hole so that the shoe can be adjusted. So that'll be sent to the beta testers once that's ready. So it'll probably be a little bit until we can have all of those parts ready for the beta testers. The beta testers get all of the updated parts so that they can upgrade to the current spec machine in production.
Mm-hmm.
So yeah.
There was another thing that I wanted to say about the limit switches. What is it? Okay, let me just think about this for a second. I lost my train of thought.
Well, I can answer Keith's question, which is what's the best way to ground the machine? We haven't really run into grounding issues because the router is grounded and the power supply is grounded, the rest of the electronics are all on the DC, right?
Yeah.
So shouldn't be an issue. I do know that the beta testers have slightly different power supplies. So if, it shouldn't be an issue.
Oh, the other thing I wanted to mention about limit switches is that you'll find on other machines they might be a little bit more popular. And the reason for that is because if the CNC router that you're purchasing is a belt-driven system instead of a lead screw-driven system, then there's the potential that when you're trying to change a bit from a larger roughing bit to a finer finishing bit, you can actually nudge the mechanics, like say the x-axis or the y-axis, so that the position of the machine is lost. So if that were to happen, then it's much more important to have limit switches in place so that you can refine your home and then hopefully find your origin from the home point. Our machine is lead screw driven on all axes, so that means that even if the machine is powered off, you can't actually move it from the position that it's currently at by just like moving it around manually. You actually have to turn the screw itself. And that way it's actually way easier to do tool changes, and it's basically impossible for you to lose your XY coordinates when you're doing the tool change. So, but as we said previously, if there's enough people asking for the limit switch add-on, we can make sure that we can release it. It's a very easy add-on, and so at the very least, we can show a tutorial on how to add the limit switches yourself, if that's something you really want.
Vacuum system. Someone's asking if the vacuum hose is compatible with the dust chute, like what sort of vacuum hose is?
Oh yeah, it's a 31 millimeter hose, which is very common with shop vacs and other like small vacuum systems. If people want to be adapting it to their large like dust collection systems, we could definitely make sure to make an adapter for it so that you can adapt it to your larger dust collection systems. And we have our own dust collection system that we can run tests on it as well. So essentially, to answer your question, it can adapt to any size. If you have a specific size that you need it to adapt to, you can let us know, and we could make an adapter for it.
Mm-hmm. Yeah, and since we're printing them as well, we have that flexibility to make it to the size you need.
Mm-hmm.
But we've tested it on our like little shop vac, and it works fine.
Yeah, and we adapted our dust collector to a smaller hose, and then plugged the smaller hose into the collector, and that works as well. So, okay. Is there any more on the Kickstarter comments?
Let me see. I don't think so. Okay. No new questions. Well, I guess if there's any, we'll give another couple minutes, like 3-4 minutes. And
1.25 inch. I think the regular 1.25 inch. I know I said 31 millimeters.
Yeah. Well, it's 25 plus like.
Yeah, it's 1.25 inch.
Yeah.
My bad.
Canadians. Okay, cool. Well,
hold on. Doesn't drop it into the table.
I think Tom just wants to have the limit switches so that it prevents it from crashing.
Oh, when you're jogging it?
Yeah.
So, okay. Yeah, Tom was saying that he was interested in the limit switches so that it prevents the machine from crashing into the table potentially. Yeah, that would be known as like a soft stop, where if you did have limit switches at the limits of the machine movement, then or that would, I guess that would be the hard stops that would exist for the electronic stops, so that the machine can't move past its limits. To be honest, you can, it's not catastrophic if you accidentally move the machine where it's not supposed to move. I understand what you're saying if you want to protect against some operator error, though. So it's a good point, Tom. Me personally, I've never jogged the Z-axis down into the bed. I think a few times I've jogged it like a bit too far, and then the end mill has pushed a bit into my material and like dented it, and that kind of sucks. But if you do accidentally move the machine past its limits in the X or Y axes, it's specifically been designed so that the motors will torque out, so you're not going to break any of your brackets or any of your other mechanics. The machine is basically just going to stop itself, and that way nothing gets broken and you can keep cutting stuff.
Okay, well, I think we'll, there's a lot of emails coming in that we have to answer, and we have to put up the FAQ.
Mm-hmm.
So yeah, we'll call it a wraps for here.
There's one comment that just came up on there.
How strong is the CNC? It's very strong. If you want to see, it's hard to describe like how rigid this machine is. That's why we put a lot of videos like with projects, so you can get an idea of what it can do. So I would really suggest everyone who's interested in seeing how powerful this machine is to go to check out our videos and go to our YouTube channel.
Yeah, to give you an idea, like the deflection that it experiences at the tool end is around 1 thou plus or minus. And like if you take a look through our projects, it's able to cut very hard woods as well as soft metals. And one of our beta testers has been using his machine because him and his wife have a custom birdhouse making business, and they've been cutting, aluminum on it as well, and brass and copper as like decorative rings and such for their birdhouses. So, it's a tough machine, and as Andy said, you can look at our videos and stuff if you want to see more about it.
We have a question from Lance asking if we're gonna add, if we can add knobs to do adjustments. The answer is you can add it. I don't know if we'll add it as a standard part of the machine. But one trick that we do use a lot is that we use this coupler here, this pulley here to. My hands are kind of sweaty, but yeah, you can adjust the Z height with that. This
is really easy for manual Z height adjustment, and then for adjusting the X-axis, you can just twist it by hand here. And then usually for the Y-axis, you don't want to be adjusting that by hand because you want to make sure that the gantries are running parallel on each side. So usually you just want to make sure you're moving the Y-axis with the machine controls through your computer. But whenever I'm using the machine for quick or small movements that I don't want to touch the computer for, then I usually just turn the lead screw by hand on the X-axis, or I take the cover off here and I do some Z-axis adjustment here.
Oh, we have another question about the repeatable location. It's about 1 thou. I would say it's probably close to 2 to 3 thou, which is less than the thickness of a sheet of paper.
Yeah.
The tolerances that the machine can hold there's a lot of factors involved, especially with like wood, for example, that kind of changes on its own. But with our testing, we've been able to get down to better than 0.05 millimeters, which I think is about just over 1,000.
Yeah.
1,000, yeah.
I mean, it'll also come down to how to making sure that you're spending the time during the assembly just to make sure that everything is tight together and you've left nothing loose, because if you leave like a pair of V wheels loose without knowing it, then you're going to introduce a little bit more deflection into the system, as well as making sure that you maintain the machine properly, because obviously if it falls into disrepair, it's not going to be able to make accurate cuts. But we've made our linear rail system in a way that you can, similar to the mill one, it's very easy to adjust the wheels that are riding on the rails, so that if they wear out over time, or they have like a gunk buildup and you need to clean them out, it's very easy to like loosen them, clean them, tighten them, or if they just wear out, you can just really easily tighten them down back onto the rails so that everything is very sturdy and back in place.
Yeah, and a lot of, we've been working with our beta testers that have done long-term testing, so we know certain things that we can do to improve the machine, like improving how the fasteners work and what things come loose sooner or later. And we've taken steps to change the design to make it a lot more stable in that way. I guess everyone wants to keep asking questions. Oh, do we lose place?
No, Thompson, no other questions on YouTube.
Okay.
Okay.
All right. Well, thanks for everyone who came out.
Yeah, thank you.
We're just almost at halfway for the backing, which is really exciting. So stay in touch. We'll keep everyone updated. And yeah, thanks. Have a good night.
Yeah, keep watching on the campaign, and if you have any other questions, let us know. So thank you for sticking with us for the live stream.